My dear students, welcome to Easy BTech, your guide for BTech and beyond. Our subject signals and systems, and today's topic we are going to discuss problems on Fourier series. Very important topic. And before going to our topic or problems, all of you subscribe, share the channel, and watch the videos regularly. It is very helpful to you. Let's start our discussion. We are going to do Fourier series problems. So he given a periodic signal. So this is the periodic signal he given. The periodic signal is given. This is the periodic signal given. So this is the periodic signal. Next, the left side also the signal is repeating up to minus infinite. Okay. So it is repeating up to minus infinity. Here x-axis is time and y-axis is the signal given x of t. Here the positive amplitude is a, negative amplitude is minus a. So time intervals here 0, pi, 2 pi, 3 pi. Similarly left side also minus pi, minus 2 pi and so on. Now the question is find exponential Fourier series. He is asking exponential Fourier series. Fourier series. So first of all, for any Fourier series, for any problem, we need to identify the fundamental time period. From that fundamental time period, fundamental frequency. After fundamental frequency, we need to write expression for given signal x of t. So these are the basic steps for any problem. Then after we go for Fourier series, right? So the same way we are following now. So the fundamental time period, so 0 to 2 pi, right? One complete cycle. From 0 to 2 pi, we have one complete cycle. So that time is capital T. So capital T value is equal to how much? 2 pi. 0 to 2 pi means 2 pi. From capital T, fundamental frequency omega naught is equal to 2 pi by T. So 2 pi by 2 pi, it is 1. So after these two, we need to write x of t mathematical definition or x of t expression. So if you observe x of t, it is a 0 to pi. So it is a 0 to pi. 0 less than t less than pi. And it is again minus a. It is again minus a pi to 2 pi. So is equal to minus a from pi to 2 pi. Pi to 2 pi. So this is the mathematical definition of x of t. So then after this definition, we go for Fourier series. So he is asking clearly exponential Fourier series. So we know definition exponential Fourier series. First we take the definition, then we proceed next. So we know that exponential Fourier series x of t is equal to the summation n is equal to minus infinite plus infinite Cn e to the power jn omega naught t. E to the power jn omega naught t. Here we need to calculate Cn. Finding Fourier series means finding coefficients. That's all. So what about Cn? Formula we know Cn is equal to What is the formula? 1 by t integral 0 to t x of t e to the power minus j n omega naught t dt. E to the power minus j n omega naught t dt. So substitute capital T, then find Cn. Okay. So here if you see capital T, the value of time period, fundamental time period is 2 pi. And our x of t is having two definitions, plus a and minus a. As per 0 to 2 pi, it is plus a, pi to 2 pi, it is minus a. So as per our x of t, we can write Cn. So first I am substituting time period 1 by 2 pi, 0 to 2 pi, x of t into e to the power minus jn. What is omega naught value? 1. So jnt dt. Right? So here we need to split the integral because x of t is having plus a and minus a, 0 to pi, pi to 2 pi. In the same way we have to do splitting of this integral. So first 0 to pi. What is x of t 0 to pi? It is a. So take a e power minus jnt dt plus again pi to 2 pi. So we go for pi to 2 pi. It is minus a. X of t is minus a. So minus a into e to the power minus jnt dt. So that's all. Then we can take common a. So Cn is equal to a by 2 pi, a by 2 pi, and perform the integration of this e power minus jnt. So e power minus jnt divided by minus jn, right? And the limits are 0 to pi. Limits 0 to pi. Next thing here, plus into minus minus. E power minus jnt integration is minus e power minus jnt divided by minus jn divided by minus jn, and limits are from pi to 2 pi. Limits are pi to 2 pi. Let's go for substitution of limits, and here we can take common jn. Okay, and minus also you can take common. Minus jn you can write outside. From both the terms, you can take minus jn common. So Cn is equal to minus a by 2 pi jn. So minus jn is common. Then substitute limits, upper and lower limits. E power minus jn pi. Upper limit is pi, so e power minus jn pi, minus lower limit is 0, e power minus 0. Okay. Next thing, minus, again substitute here upper and lower limits, e power minus jn 2 pi, minus lower limit is e power minus jn pi. Limit substituted. Then go for values of this exponential terms. So e power minus jn pi. How to write this? Cos n pi minus j sin n pi. Right or not? Like that. E power minus 0 or plus 0, it will be 1. Right? And e power minus j n 2 pi. Cos n 2 pi minus j sin n 2 pi. Similarly, e power minus j n pi. So we are going to write that exponentials. So Cn is equal to minus a by 2 pi jn. Cn is equal to minus Cn is equal to minus a by j 2n pi, right? Minus a by j 2 pi n or 2n pi. So e power minus jn pi we have, it can be written as cos It can be written as cos n pi minus j sin n pi. Sin n pi. And here we have cos e power minus 0, it is 1. So, minus 1, right? Again, here we have e power minus j 2n pi. Let's take that. So, minus cos 2n pi minus j sin 2n pi. Sin 2n pi. And what about this e power minus j n pi? Again, cos n pi minus j sin n pi. Minus cos n pi minus j sin n pi. So this is about exponentials. Whatever we have, we written. Then see the values. What is cos n pi value? What is sin n pi value? What is the cos n pi value? Minus 1 power n. What is the sin n pi value? 0. Here minus 1 is as usual. Again cos 2n pi value. What is the cos 2n pi value? 1 plus 1. What is the sin n 2 pi or 2n pi? It is 0. Again cos n pi value. What is it? Minus 1 power n. Means it may become plus 1 minus 1. That is minus 1 power n. Sin n pi value 0. So sum or add all. So Cn is equal to Cn value minus a by j 2n pi into minus 1 power n minus 1 power n. Here we have minus 1, right? Again minus of. Here again 1 we have. Again minus of minus 1 power n. Right? So here we have minus. This minus 1. And here we have minus. So here you can see these two are cancelled. Here plus minus 1 power n, here minus 1 power n cancelled. So Cn is equal to minus a minus 1 minus 2 divided by j 2n pi. So minus will become plus and 2 cancel. So a by j n pi. This is the value of Cn. Okay. And if you want to know C naught, so if you substitute n is equal to 0 in Cn, wherever n is there, if you substitute 0 here, then a by 0, infinity we get. So which is a wrong answer. C naught is not correct, infinity is not correct. So to get the correct value of C naught, so how to get the C naught value, correct value? Any idea? So C naught is equal to A naught, and we have A naught is integral 0 to t x of t dt. So direct integration of x of t and divided by t. Then we get the C naught or N. Both are same. This relation already we know, that is why we are following. Let's do this C naught. So if you see, here I am continuing, t value 2 pi and limits 0 to 2 pi x of t dt. So as already we know, x of t is plus a and minus a. Plus a is from 0 to pi, minus a is from pi to 2 pi. So that is why we have to split the integral. So 1 by 2 pi integration 0 to pi, it is a plus Integral pi to 2 pi, it is minus a. Right? So do the integration and substitute the limits. We have the answer. Here a and a you can take common. So a by 2 pi. So here integration of 1 t, upper limit pi. So you get pi here. Lower limit is 0, so 0. Plus into minus, minus. Here upper limit is 2 pi and lower limit is pi. Right? So this value, how much? Simplify this. A by 2 pi. A by 2 pi. Pi. Here minus 2 pi plus pi. So plus pi plus 2 pi. 2 pi minus 2 pi. 0. So 0 by 2 pi is equal to 0. So this is the value of C naught. So what is the value of C naught? 0. So this is a way of doing C naught correctly. Whenever you have C naught is infinity from Cn, then we go for actual C naught formula to get actual value of C naught. Right? Next thing, another problem we are taking, very important thing. Very important problem. So we have train of impulses. This is the impulse. Again it is repeating. Again the impulse is repeating. Again it is repeating. Train or series of impulses. Repeating. It is repeating. Right? So this is the signal he given. So for this signal, we have to do exponential Fourier series. So this is the impulse at 0, at t, at 2t, at 3t, and so on. These are all impulses. Series of impulses he given. Here minus t, minus 2t, and so on. So series of impulses he given. This series of impulses signal I am representing as del t of t. The given signal we are taking as del t of t. So for this series of impulses or train of impulses, what we call series of impulses. Series or train of impulses. So determine the exponential Fourier series or find exponential Fourier series. Exponential Fourier series. So how to do? Very important, right? So as I already told you, whenever you are going to do Fourier series problem, we must identify the time period, fundamental time period and fundamental frequency. Then x of t, given signal definition. Then we go for finding coefficients. So here we have impulses, series of impulses. Okay. So now I am considering here the time interval minus t by 2 to plus t by 2. So here we have a impulse, one impulse between these two. Again another impulse, it is repeating. So this interval is t by 2 and here we have minus t by 2. The total time period, fundamental time period is how much? Minus t by 2 plus t by 2, how much? T. So t is the fundamental time period. Right? And what is the angular frequency? Omega naught is equal to 2 pi by t. T itself only, 2 pi by t. That's all. And what is the del t of t? Expression of given signal. That is del t of t. So if you observe from minus t by 2 to plus t by 2, we have an impulse that is located at 0. We have impulse at which is at 0, right? That means impulse at t is equal to 0 means del of t. Del of t or not impulse function we discussed already in the first unit or in at the starting we have seen. So del t of t is equal to del of t where to where? Minus t by 2 to minus t by 2 less than t less than plus t by 2. Right? If you observe minus t by 2 to plus t by 2, we have impulse at t is equal to 0. That means del of t. So let's start our exponential Fourier series. Given what is exponential Fourier series? Definition first we write x of t is equal to summation n is minus infinite to plus infinite Cn e to the power jn omega naught t. So here we calculate Cn or we determine Cn. Cn is equal to 1 by t integral 0 to t x of t e to the power minus jn omega naught t dt. Minus jn omega naught t dt. So here integration limits 0 to t over one period or one time period. So we can take limits minus t by 2 plus t by 2 also, which is equal to one time period. Right or not? So there is no guarantee to take the limits always 0 to t. As per the given problem, as per the time period you taken or chosen, one cycle you chosen, in the same way we can change the integration limits in Fourier series coefficients. It may be trigonometric Fourier series or exponential Fourier series. So please remember this point and follow. So Cn is equal to 1 by t, here integral limits minus t by 2 to plus t by 2. Okay, minus t by 2 plus t by 2. What is x of t? X of t means given signal del t of t. So minus t by 2 plus t by 2. What is del t of t? It is del of t. So take that del of t into e to the power minus jn omega naught t dt. Minus jn omega naught t dt. So here we have product del of t into e power minus jn omega naught t. First we discuss about this product, then we go for integration. That's all. Okay. So let's see that product. What is the product we have? We have del of t into e to the power minus jn omega naught t. So what will be the result of this? Del of t is multiplied by e power minus jn omega naught t. So del of t will exist only at t is equal to 0, right? The place or location of del of t is at t is equal to 0. So whenever you are multiplying del of t by any signal, that signal only multiplied at t is equal to 0 only. At t is equal to 0 only. That means del of t into e to the power minus jn omega naught into 0. Simply you take the location of del of t or impulse. That location you substitute in the next function or next signal. Then we get the multiplication result. So e power minus 0 or plus 0, it is 1. So we get del of t. We get del of t. This is the multiplication. So this multiplication we consider, we take into Cn. Now Cn is equal to 1 by t integral minus t by 2 to plus t by 2 minus t by 2 plus t by 2. Here the product value we got del of t. The product is del of t. So I am taking del of t. Right? And this integral indicates now. What this integral indicates? Integration minus t by 2 plus t by 2 del of t dt. Area under impulse. This integral is area under impulse. Area under impulse. So how much the area under impulse? Always 1. This value is 1. This integral value is 1. Therefore, what is the result we get? Cn is equal to 1 by t. The value of Cn is 1 by t. Right? So very, very important problem and easy. Okay. So now we can write given signal x of t, or in the place of x of t, that is del t of t. So we can write answer now. Del t of t is equal to summation n is equal to minus infinite plus infinite. Here Cn, what is the Cn we got? 1 by t e to the power jn omega naught t. Omega naught t is, you can write 2 pi by t. Omega naught t. So this is the final result. Okay, let's take another problem. So take the periodic signal. This is the periodic signal given. So it is repeating, and similarly left side also it is repeating. So this is the periodic signal. It is repeating itself, right? So here 0, it is passing through origin, and here we have minus, this is t by 2, and this is minus t by 2. Okay, and this is t, and this is minus t, minus t, minus t by 2, 0, t by 2 plus t. X-axis t, and the y-axis x of t, and its peak amplitude is a, and the negative peak amplitude minus a. So for the given signal, find trigonometric Fourier series. Find trigonometric Fourier series. Okay. If you observe the signal, this signal is satisfying odd symmetry. It is passing through origin, and if you take the value of the signal or amplitude of the signal at t by 2, it is a. At minus t by 2, it is minus a. Opposite. Plus t by 2, it is a. Minus t by 2, it is minus a. Okay. So satisfying odd function or odd symmetry. So the given function satisfying or given signal is odd symmetry. Is odd symmetry. That means, what is odd symmetry? X of minus t value will become minus of x of t. So simple. X of minus t value will become minus of x of t. The amplitudes are opposite. Positive time, negative time. Okay? Here negative time, here positive time. Amplitudes are opposite. Simple relation, simple meaning. So the given signal is following that. It is odd symmetry. So odd symmetry means, in trigonometric Fourier series, odd symmetry means a0 value is 0 and an value also 0. Only we get bn. We obtain bn, or we will get bn. That is odd symmetry. Already we discussed. So first write fundamental time period. As usually for all problems, what is the fundamental time period? One cycle we need to choose. So minus t by 2 to plus t by 2. This is the one cycle. Minus t by 2 to plus t by 2. Again same is repeating. So this is the fundamental time period. Capital T itself. Okay, minus t by 2 plus t by 2, it is capital T. What is fundamental frequency? Fundamental time period is t, and fundamental frequency omega naught, 2 pi by t. That's all. 2 pi by t. Okay. And we need to write the given signal expression, x of t expression, from minus t by 2 plus t by 2, because we have taken the fundamental time period, indicated time, fundamental time period from minus t by 2 plus t by 2. So what is the equation from minus t by 2 plus t by 2? That is the x of t expression. So a line passing through origin, the equation is y equal to mx. The same way we can get the x of t expression. Line passing through origin, y equal to mx. So here also a line passing through origin. Okay. y equal to mx. Here y means y-axis, x of t. M is the slope. So how you get the slope? Y2 minus y1 by x2 minus x1. So here you take 2 points. This line. This point is x-axis is t by 2. So t by 2 comma y is a. This is the a. T by 2 comma a. Here also point. This point. What is x-axis here? Minus t by 2. And what is y? Minus a. What is y? Minus a. So y2 minus y1, a minus of minus a, it is 2a divided by x2 minus x1, t by 2 minus of minus t by 2, it is t. Right? Into x. What is x-axis here? T. So t. So 2a by t into small t. So where to where we have written this minus t by 2 to plus t by 2. That is also important. Interval. Minus t by 2 less than t less than plus t by 2. Okay, done. Next thing, we go for bn. Already a0 is 0, an also 0. So we go for bn. What is the bn formula? Coefficients bn 2 by t integral 0 to t x of t into sine n omega naught t dt. Sine n omega naught t dt. Okay. So let's take x of t here. And here the limits not 0 to t here because we are taking one cycle minus t by 2 plus t by 2. So limits will be in the same way. We have to take, as already we discussed, not always 0 to t. That depends upon given signal, given function, and where to where you choose a time period. Okay, according to that limits we need to take or we have to follow. So t is t itself, and here minus t by 2 to plus t by 2. Understand? Minus t by 2 plus t by 2. What is x of t here? 2a by capital T into small t into sine n omega naught t. Sine n omega naught t. What is omega naught here? 2 pi by t. So sine n 2 pi by t dt. Otherwise we can keep omega naught. At the final omega naught we can take as a 2 pi by t. Okay, no issue. Then 2 into 2, 4a by t square, 4a by t square. Here t into integral minus t by 2 to plus t by 2 into t into sine n 2 pi by capital T dt. So integral uv we follow now here because u is t here, sine function also t, integration also t. So uv we follow. Now 4a by t square bn is equal to 4a by t square and uv integral u integral v t sine integration minus cos n 2 pi by t and divided by n 2 pi by t minus u dash means t derivative is 1 integral v sine derivative minus cos, so it will become cos, again cos derivative sine, so sine n 2 pi by t divided by, here you get n 2 pi by t whole square. Limits are from minus t by 2 to plus t by 2, right? Once we verify minus t by 2 plus t by 2, 4a by t square here, u is t sine integration minus cos minus u dash t derivative 1 sine integration minus cos, again cos sine, right? Just to verify. Now go for substitution of upper and lower limits, simplification, mathematical simplification. So bn is equal to, and we can take common n 2 pi by t, we can take common. So 4a by t square n 2 pi by t. Upper limit is here capital T by 2. Okay. So capital T by 2 into cos minus cos n 2 pi by t into t by 2. Right? Upper limit we are substituting, and in the same way, in the same term, lower limit I'm going to substitute. So what is the lower limit? Minus t by 2. So here minus t by 2 cos n 2 pi by t into t by 2. Here cos, here minus t by 2, cos minus theta is cos theta only. So I written that cos minus theta as a cos theta. So for the first term, we substituted upper limit, right? And we also substituted lower limit. This is the upper limit, right? T by 2 minus sign I written outside. T by 2 cos n 2 pi by t by 2. And minus lower limit minus t by 2 cos n 2 pi by t by 2. That's all. And similar way we go for second term, this sine term. So close the bracket, plus sine n 2 pi by t. Here small t is t by 2, upper limit we are taking by, okay, we can take by later, minus lower limit sine n 2 pi by t minus t by 2. Sine minus theta is minus sine theta, so minus will become plus t by 2. And this total is again divided by n 2 pi by t, because 1 n 2 pi by t we have written outside. So this is a thing we have, right? And here we can do simplification. Here tt get cancelled in cos function. Here also tt cancel. Here tt cancel. T cancel. Then here sine n 2 pi. Here 2 also get cancelled. In the same way 2 get cancelled. Right? Okay, done. Next, here cos n pi. So we know cos n pi is minus 1 power n. So cos n pi value minus 1 power n. Right? Cos n pi minus 1 power n. Here also cos n pi. This value also minus 1 power n. I am writing values of each term. Sin n pi 0. Sin n pi 0. Okay? Sin n pi 0. So these two terms are zeros. So let's take remaining terms. Let's write remaining terms. And here also see cancellations 2 times. Here t 1 time cancel. So bn is equal 2a by here we have n pi and t. So tn pi minus t by 2 minus 1 power n. Here again minus plus minus plus t by 2 minus plus t by 2 minus 1 power n. Minus 1 power n. Okay. So now, if you take n is even odd, what happens? If n is equal to even, what happens? Minus 1 power even plus 1 minus 1 power even plus 1 minus t by 2 plus t by 2 cancel. And if n is odd, So here Bn also becoming 0. Bn also here minus t by 2 minus 1 power n plus t by 2 minus 1 power n. Okay. So here minus is common. Once I will verify. Minus is common. Upper limit is t by 2 cos 2 pi by t and upper limit is t by 2 minus lower limit minus t by 2. So here minus t by 2 cos 2 pi by t by 2. It's okay. And in the second term, upper limit, lower limit. Okay. So here, so this minus sign is there. That minus sign we need to consider. Here close the bracket clearly. Okay. Minus sign is outside. That I am writing outside. Right. Done. Clear? Here minus into minus plus t by 2. So simplify this. Not bn is 0 here. So because here we have minus sign outside. That is a clarity. So minus 2a by t n pi. Here t by 2 minus 1 power n plus t by 2 minus 1 power n. 2 times. So 2t by 2 minus 1 power n. Right? Here t get cancelled and 2 also get cancelled. So remaining is the bn. So what is bn now? This implies bn is equal minus 2a by n pi minus 2a by n pi minus 1 power n. This is the value of bn. Minus 2a by n pi minus 1 power n. Right? So problems we discussed more and more. Right? So simple. So you just one thing, follow, watch videos, follow every video, listen every video. You can understand well, you can do well. Thank you students.